Okay. All right. So next step on operating procedures here. Satellite operations, satellite and space station contacts. It is possible to make contact. Well, first off, the ISS has a repeater on it. Okay, so it's possible to bounce off of that repeater and make contact at a greater distance away, but it does take a good antenna, a good eye, and you've got to have a little bit of. I've reached it. I've never actually made any contact through it, but I have reached it and got a return from it. But yeah, it's hard to reach it with a 5-watt radio. But you can do it. Has anybody ever watched a space station pass over? A dude books across the sky. I mean, if you can catch it going, 60 or 70 degrees over, it's still from horizon to horizon. You're looking at maybe 6 or 7 minutes max. And a lot of times when it's lower, because you can't view it closer to the horizon. There's too much stuff in between. But, if it's only going at like 15 degrees across, you might get it for a minute and a half or 2 minutes. And that one will be tougher to reach on the repeater. If it's going 50, 60, 70 degrees overhead, you'll have a much better chance of making a contact on there. But VHF, UHF, technician class or higher, frequencies, you have an uplink frequency and a downlink frequency. So when you see UV rather than, this gets confusing because when you look at your Bofang radio, the model is UV, and that means UHF, VHF. But when you see UV or VU in this particular context, it's talking about the uplink and downlink. The uplink is always listed first, the downlink second. So if you see that the satellite is UV, that means your uplink is UHF and the downlink is VHF. If you see it VU, it's the opposite, VHF up and UHF back down. So it takes a special step when you're setting up this repeater on your radio. It takes a special step because you have to cross. It has to have a cross. It's not going to automatically pick your offset because your offset is completely off the table in this case. Modes, single sideband, FM, CW, or data. Which amateurs may contact the International Space Station on VHF bands? Any amateur holding a technician class or higher license. I always thought the novice got the same privileges as a technician, but they didn't mention that on there. What is meant by the statement that a satellite is operating in UV mode? Anybody else? Okay, Greg says Bravo, and Bravo is correct. UV means UHF going up, VHF coming back down. Remember, the uplink is first, the downlink is second. So 70 centimeters going up, that's UHF band. 2 meters coming down, which is in the VHF band. What mode of transmission is commonly used by amateur radio satellites? Delta, all of these are correct. Single sideband, FM, and CW data. Satellite power limits. Automatic gain control operation. Strong signals cause blocking of weaker signals. So there's a rule in amateur radio that you should never exceed the minimum amount of power required to make the communication. Okay, that's the standard rule. So I got a guy on ground wave one time, his name's Eric, while I was out on a QRP. But I was, I was doing QRP, and I started talking to him. Come to find out, he was only 3 miles from my location, and he's running 800 watts. And he said, "Give me just a second." So he disappeared for a few seconds and came back and said, "I just needed to turn my amp off." He said, "There's no need to send out 800 watts to talk to somebody 3 miles down the river." So, but yeah, you should always only use the amount of signal required. Now, in this case, stronger signals will block weaker signals, but it also drives the AGC in their radio. So if they're getting a signal real strong, then their AGC and becomes active and knocks their signal down a little bit because they figure they're closer. The radio thinks it's closer. Uplink and downlink beacons can be used to verify uplink power. Downlink power should be same as the beacon. What is the impact of using excessive radiated power on a satellite uplink? Bravo, blocking access by other users. Which of the following is a way to determine whether your satellite uplink power is neither too low nor too high? Your signal strength on the downlink should be about the same as the beacon. Okay. Okay, LEO, LEO, low Earth orbit satellites, 99 to 1200 miles, 88-minute to 127-minute periods, high bandwidth and low lag time. What is a LEO satellite? Satellite in low Earth orbit. That is correct. Amateur satellite operation, beacons, telemetry transmissions. Most satellites are equipped with beacons. Transmission of health and status information comes from the beacon. Voltages, currents, and temperatures, etc. Non-military, there are available to anyone. If they're military satellites, and you're not going to have access. And this is a chart that shows some of the satellites and where you can find them. What is a satellite beacon? A transmission from a satellite that contains status information. That is correct. What telemetry information is typically transmitted by satellite beacons? Charlie, health and status of the satellite. Who may receive telemetry from a space station? Alpha, anyone. Satellite tracking. Many computer programs provide maps with real-time tracking, time, azimuth, and elevation of a pass, apparent frequency and Doppler shift, control of an antenna, and requires input of Keplerian elements. Does anybody track okay, so I've got this app on my phone called ISS, or Spot the ISS. No, actually, it's not an app. It's a web page that I've got bookmarked called Spot the ISS, and it'll give you the next several passes. It'll tell you, you put in where you're at, and it'll tell you where the next several passes are. But for others, you've got the computer programs. Let's see. And there is a diagram of ISS that looks like 2005. So I'm not sure what the program is. Orbitron 3.51, I think is what it says. Mm-hmm. Yeah. And that, uh, like I say, if you've ever watched it go over, it is remarkably bright. I mean, it'd be have a hard time confusing it for a star because of its brightness and how fast it moves. Which of the following are provided by satellite tracking programs? Delta, all of the above. Which of the following are inputs to a satellite tracking program? Bravo, the Keplerian elements. Where are those found, Bob? Okay. 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 All right. So satellite communication issues. Doppler shift is a big issue and probably the most common because once you spot it in the sky, I mean, everything's moving. The Earth is moving, the satellite's moving. Apparent frequency shift, Doppler shift is apparent frequency shift due to relative motion. So the difference in motion between the way the Earth is rotating and the movement of the satellite gives a frequency shift. Spin fading. Does everybody know what Doppler shift is? Okay, if you don't know what Doppler shift is, if you're sitting in your car at a train track and the gate's down and you're sitting there waiting for the train to go by and it's coming from over here and the sound of the whistle has one tone, and then when it goes past you, the sound of the whistle has another tone, and that's an example of Doppler shift. Spin fading is caused by rotation of the satellite and its antennas. And this can also change polarization. Remember when we discussed polarization, if you're talking on a radio and your antenna is straight up, so if the antenna up there is not oriented the same way, then it's going to cause a decrease in your signal. You got the right equipment, you may still be able to hear them, but the signal is going to drop off a little bit. So, yeah, that's caused from, motion of the satellite up there. What is a Doppler shift in reference to satellite communications? Charlie, an observed change in signal frequency caused by relative motion between the satellite and the Earth. What causes spin fading of satellite signals? Bravo, rotation of the satellite and its antennas. So takeaways on this part are amateur satellite operation, International Space Station contacts, any technician license or higher licensee. UV mode is 70 up, 2 meters down. Remember, the first one is the uplink, the second one is the downlink. So if it's VU, it's the other way around. Supported modes are single sideband FM, CW data. Excess power can cause block other users. We want to be a good neighbor here when we communicate with it. Your downlink signal strength should be about the same as the beacon signal coming from them. LEO, low Earth orbit satellite. Beacons, a transmission from a satellite that contains status information will contain health and status of the satellite. And anyone can receive that as long as it's not a military thing. Satellite tracking programs show maps of the real-time position of the satellite track over Earth, displays time, azimuth, and elevation of the start, maximum altitude, and end of a pass. Shows the apparent frequency of the satellite transmission, including effects of Doppler shift. The Keplerian elements are the inputs? What tells the computer to model it? And observed change, communication issues. You've got Doppler shift, which is an observed change in signal frequency caused by relative motion between the satellite and Earth station. So your frequency, your receive frequency may have to be modified a little bit. Spin fading is rotation of the satellite, or it caused by rotation of the satellite and its antennas. Any questions?